Before we begin our study of calculus, we need to have a firm grasp on the concept of limits. We already know that if you have a function, you could be asked to evaluate that function at a given point. For example, you could be asked to evaluate f of 2. Well, we're going to learn today that you could also be asked to find the limit as x approaches 2 in a given function. Of course, to find f of 2, you just plug 2 in for x into this function. 2 squared is 4, 2 times 2 is 4, 4 plus 4 is 8, and 8 plus 3 is 11, so we could say f of 2 is 11. Now, most of the time, evaluating the limit as x approaches 2 is exactly the same as evaluating f of 2. In this function, that's the case. It's exactly the same. The limit as x approaches 2 is 11. But finding a limit is not always the same as evaluating a function. In this function g of x, we're going to see that the limit as x approaches 3 is not the same as evaluating g of 3. To evaluate g of 3, I'd plug 3 in for x. 3 squared is 9, and 9 minus 9 is 0, divided by 3 minus 3 is also 0, and we know in math you can't divide by 0. G of 3 is undefined. Well, we're going to see in this lesson that this function g of x does have a limit as x approaches 3. Believe it or not, the limit as x approaches 3 is 6. In today's lesson, we're only going to evaluate these limits visually and numerically.
I find it easiest to explain limits by comparing and contrasting it with something you already know how to do. You already know how to evaluate f of 2. Evaluating f of 2 visually is essentially what you're asking a calculator to do when you trace 2. We go to where x is 2, and we look up and down to see where the graph is. Now in this situation, there's a hole in the graph. My pencil just slips right through the graph. I'm going to say that f of 2 is undefined. However, I now want to show you that there is a limit as x approaches 2. From the left side, as this graph approaches 2, it's clearly headed towards the point 2, 4. Even though the graph doesn't go through the point 2, 4, this graph is headed towards the point 2, 4. Likewise, if I approach it from the right side, it's headed towards the point 2, 4. On both sides, it's headed towards the point 2, 4. The limit as x approaches 2 is 4. It need not matter that the graph doesn't go through the point 2, 4. The graph is headed towards the point 2, 4 from both directions, so the limit as x approaches 2 is 4. Let's look at this function and evaluate f of 5. I'll go on the x-axis to 5 and recall that a function can only have one output at a given input. So when my input is 5, the function goes to this point right here. The output is 3. f of 5 is 3. Now, let's talk about the limit as x approaches 5. I drew a line where x is 5 with my pencil. As we approach this line from the left side, the graph is clearly headed towards the point 5, 3. However, as we approach this line from the right side, the graph is headed towards the point 5, 6. On the left side, we're headed to 5, 3. On the right side, we're headed to 5, 6. It's not headed to the same place from either side. I'm going to say that this limit does not exist. Perhaps you can see that this function has an asymptote at -4. Therefore, f of -4 is undefined. The graph never crosses this asymptote of -4, so there's no output at -4. Let's talk about the limit as x approaches -4. This asymptote is where x is -4. As we approach it from the left side, we appear to be headed towards the point -4, infinity. As we approach the asymptote from the right-hand side, we seem to be headed towards the point -4, infinity. On the left side, the graph is going up to positive infinity. On the right side, the graph is going down to negative infinity. I'm going to say that this limit does not exist. Here we have a very common function, a parabola, f of 2. Well, if I go to where x is 2, I see that the graph goes to this point right here, 2, -3. So f of 2 is -3. Once again, I drew a line where x is 2 with my pencil. As I approach this line from the left side, the graph is headed towards the point 2, -3. As I approach this line from the right side, the graph is also headed towards the point 2, -3. From both directions, it's headed towards the point 2, -3. The limit as x approaches 2 is -3. This graph has an asymptote where x equals 3. The graph does not cross where x equals 3. Therefore, f of 3 is undefined. Now, as I approach where x is 3 from the left side, the graph is headed towards 3, infinity. And as I approach where x is 3 from the right side, the graph is also headed towards 3, infinity. We can say the limit as x approaches 3 is -infinity. It's headed towards 3, infinity from both directions. However, some mathematicians argue that infinity is not a real number, so we can also say this limit does not exist. Negative infinity or does not exist are both acceptable ways to express this limit. Let's take a look at this function and evaluate f of 1. Notice that where x equals 1, there is no output. If you look up, my pencil will slip through that hole, and if you look down, my pencil will slip through that hole. I'm going to say that f of 1 is undefined. Let me draw a line where x is 1 with my pencil. As I approach this line from the left-hand side, my graph is headed towards the point 1, negative 3. I know it doesn't actually go through the point 1, negative 3, but it's headed towards 1, negative 3. As I approach that line from the right-hand side, the graph is headed towards the point 1, positive 3. The left-hand side is headed towards 1, negative 3. The right-hand side is headed towards 1, positive 3. They're not headed the same direction. This limit does not exist. In this function, if I evaluate f of 2, if I go to where x is 2, the output is 1. This graph goes through the point 2, 1. However, I'd like to show you that the limit as x approaches 2 is not 1. Let me once again draw a line with my pencil where x is 2. As I approach this line from the left-hand side, the graph is headed towards the point 2, 4. As I approach this line from the right-hand side, the graph is headed towards the point 2, 4. From both directions, the graph is headed towards the point 2, 4. The limit as x approaches 2, we say, is 4. This last example has a hole in the graph where x is 2, so f of 2 is undefined. This graph has no output when x equals 2. Let me draw a line with my pencil where x equals 2. But this graph does have a limit when x approaches 2. As I approach that line from the left-hand side, the graph is headed towards the point 2, 5. Even though the graph doesn't go through the point 2, 5, this graph is headed towards 2, 5. And from the right-hand side, it's also headed towards the point 2, 5. From both directions, it's headed towards the point 2, 5. We say the limit as x approaches 2 is 5.